What I wanted to talk about today is transparency and something called explainable AI, which is often referred to as XAI in the literature. So if you've studied this at all, you've probably seen XAI. Transparency is kind of a huge topic. There's a lot of different ways different directions we can go with transparency. I mean, we could be asking, well, what does that exactly mean, and what needs to be transparent? Who are we talking about? Is it the company? Is it the product? Like, what needs to be transparent, and who do we answer to? So that's very big and broad, and I don't want to talk about all of that. We don't have enough time. So I just wanted to kind of laser focus in on just one aspect of transparency, and that's explainable AI. So AI, machine learning, these are all considered black box models, especially when you get into like really complex models. They're they're complex. You don't really understand what's going on. The things that come out of them, you often don't really know where they came from, right? So large language models, generative models, this is all the new stuff. But even before all of this, just with regular old machine learning models, classical machine learning, it was the same thing. You have these neural networks, or even any tree-based method like random forest, XGBoost, gradient boosted machines, all those things. They're all black box. And so even with just simple predictive modeling, if you're asked to explain what your model is doing, how it works, how is it making predictions, even with those types of models, it's very difficult. And so I got into this, in industry because especially in healthcare, which is heavily regulated, we did have to answer for our models' predictions, and the effects that our models had in healthcare. We often would get approached with questions as to what was going on. And basically, the question we were always getting was, why did the machine learning model or the AI system make the decisions or the predictions that it did? Okay, so explainable AI is typically around this question. It's like, can you explain why the AI made the decisions that it did? And so, like I said, specifically in healthcare, we did have models that would make predictions. Those predictions would impact patients, and those patients would then ask why. It's like, why would, you know, the company I was at, it was on the healthcare claims side. So, every time you go to the doctor, your doctor fills out a claim, they send it to the insurance company, and then our models would predict something about that claim and then send it back to the doctor. And, the doctor might have to make changes to it and things like that. And so like when that happened, it could be really disruptive to the patient. And then the patient could come and say, well, why? Like, why do we have to make these changes? What happened? Why isn't my claim just getting paid? And so those requests would then come to us and we would have to answer this question, right? This question right here. And how do we answer this question? Explainable AI. It's like there are a whole suite of methods and tools out there for answering these types of questions. So when I teach the ethics class here for our graduate students, there's so many different topics in AI and data ethics, as you know, right? Algorithmic bias, privacy, and then transparency, and then others as well. Every lecture I start off with, here's the topic, and then I ask the question, why? Why do we care? Like, why do we care about this topic? And it's really easy to answer it with just a bunch of headlines. You just go out, do a quick Google search, you'll find no shortage of news headlines of AI or machine learning behaving badly, right? So it's really easy to go out and just see, well, these are the problems. These are the problems with algorithmic bias or with data privacy or with transparency and explainable AI, because this is what happens. This is what happens when you don't think about these things. It impacts people negatively. So I start all of my lectures with this, it's just kind of a scatter shot of these headlines. I'm not going to talk about all of these specific instances. There's so many of them, right? I mean, it's limitless. So I thought maybe instead we could just think about a few different domains where AI or machine learning is applied, especially domains that, I think we would all agree it might be important to be transparent, for companies to be transparent with what their AI is doing, to be able to actually answer that question, why does the model make the predictions that it does? And so, you know, upper left here is medicine and healthcare. I think that that's kind of obvious. It's one of the classical examples here for explainable AI. You go to the doctor's using AI to look at your imaging, your X-rays, your MRIs, and trying to identify tumors or whatever, or other types of like disease detection algorithms are out there, right? And so as a patient, you might think, I want to understand how those things work. If the doctor's using it, I want to know how it works. Autonomous driving, I think, is another kind of no-brainer. Why do cars sometimes do weird things? I don't know if any of you have seen any of the driverless, autonomous vehicles out there. I'm not sure how popular it is in Austin, but here in San Francisco, Waymo, they're all over the place. And sometimes you see them do weird things. Sometimes they stop in the middle of the intersection and they don't move. Sometimes they block the emergency vehicles. Sometimes they swerve for weird reasons. So, it would make sense, especially as a passenger, you might want to know like what's going on, right? And why is it doing these things, making these decisions? Another classical example is finance and credit scoring, because with those types of models that are running, people might get denied applications for loans or for credit cards, right? It really does impact people financially, and sometimes unfairly, and that's a whole different topic when you talk about algorithmic bias and fairness. Criminal justice, if you're studying AI ethics, you have probably heard of the Compass model. If you haven't heard of the Compass model yet, you will eventually. So there are models out there that if you are arrested, they try to predict whether or not you would be likely to reoffend if you are released out into the public. And then judges can use these models to determine if you should get bail. If parole boards might use them to decide if you should go out on parole. Sometimes judges might mistakenly use these models to actually determine your sentencing, right? So, especially if you're on the receiving end of that model, you may want to understand why, right? Why are these decisions being made about your life? And then the last one is warfare. I don't really know much about what actual AI is being used there. Of course, that's very secretive. But sometimes you hear that AI is being used, for targeting, right? Finding targets. And so, again, something that could impact somebody's life in a negative way, you might want to be able to understand how it works. So there's more, this is not a comprehensive list. These are just a few areas. I'm sure you can think of more. AI is impacting your daily life all the time. It's just sometimes it's maybe in a seemingly trivial way. But so I just kind of went over a bunch of examples, but I didn't really say exactly why we care about this. And so, these are just a few reasons, kind of a subset of reasons why we still might want to answer that question. Why does the AI make the decisions that it does? So the first is trust. We fear what we don't understand. And so if we don't understand it, we're less likely to adopt it. Again, if you don't understand AI, you find out your doctor's using it, you may lose trust in your doctor. Then you might want to try to find a new one, and that might not be the right decision, right? So the more trust we have in the AI system, and then the more likely we are to adopt it and to actually use it. Fairness is a big issue in all of AI and machine learning. We know this. Explainable AI can help with that. If you can actually understand why the model makes the decisions it does, you can start to answer the questions about fairness. Is it an actual fair model? Because they should be. And I know there's all kinds of definitions of fairness out there, but in order to understand how fair a model is, and we do need some explainability that's in the model. Empowerment is for us, the consumer, right? The customer, people using these AI systems. If we can ask for an explanation, that gives us power, sort of gives us some control over our own lives, give us some control over our own, it's for our autonomy, right? That's a big part of AI is that everybody should retain their autonomy, and if they can't, then they probably should not interact with that AI. And so being able to get explanations gives us some power, which is good. on the company side, there's if the consumer is allowed to ask for an explanation, then that means it should be required. It should be compulsory for the company to offer it, right? And so companies may want to be able to explain their models because they have to, because of some regulatory reason. Like in healthcare, at the company I was at, if a customer asked, why was their healthcare claim, not paid? Uh, we would have to answer that. The Department of Insurance would come to us and ask us for an explanation, right? And how did we answer that question? We used explainable AI. Companies also might want to do explainable AI for improvement. So obviously they want to make the best model possible. So how do you make a better model? Is like the better you understand it, the better you can make it. Okay. So the more you can answer that question, then you can think of ways that you can then improve the model and make it even better. So there's some benefits to it on the company side and also on the consumer side. All right, so those are I think all those are good reasons. There's like a more like sort of philosophical uh, reason we might care about this too, which is just um, if we're going to use these AI systems, we want to make sure that the decisions it's making are, good. Like we want to understand, good and bad decisions. And in order to understand those, um, then we need explainable AI. So it's not really specific to the outcome, to the consequences of the AI. It's just that we know we need to understand what are good and bad decisions. And so in order to understand that most completely, then we need to be able to answer that question as to why it makes those predictions. So that's more philosophical, and if you're into that, I think that's maybe that's a good enough reason for you. You don't care about the consequences. We need to understand what we're using, so that we can make sure we're making good and bad decisions, or what are good and bad decisions. Okay, so for me, as a data scientist, especially when I was working, I wasn't thinking so much philosophically. I mean, of course, some of those things about trust and bias I was thinking about, and I cared about those things deeply, but I was also very interested in like, well, what are our actual technical solutions? Like, how can I, as a data scientist, help to answer these questions? And so luckily, this is a huge field, explainable AI. It's been around for decades. It's just very popular now, of course, with the explosion of data and machine learning and all that. Um, but there's, no shortage of research that's going on. Maybe you're doing research in this already. So I wanted to kind of go over some of the tools that we have in our toolkit for explainable AI. And at the same time, try to convince you that none of them are really good enough. Okay, so that most of them don't really answer this question directly. And it's kind of maybe they give an indirect answer, but they're not really adequate. Okay, and that's definitely how I felt when we were explaining our models, predictions, at my last company. So the first one, most people would say this, are interpretable models. Um, they're these are the generalized linear models. You can put it out there. You can print it out as a formula. It's pretty obvious. You can interpret coefficients, like all those x's are just features in your model, and then you estimate some coefficients, and then they have a very natural explanation. If you take a regression class, you've already done this plenty of times. So nice, simple, interpretable models, sort of easy to explain. On the right, decision trees, or like rules-based systems, rules and lists, logical models. Those are also pretty easy to explain to anybody. You just say like, if somebody's age is, greater than 30, their income is greater than $100,000, then they should be approved for this loan, right? So it's like a bunch of if-then statements, really easy to explain to people. I should note here that there is a difference between interpretable models and explainable models. I won't go into the details of that, but when you want to explain your predictions, and then these models are interpretable in that they're so simple you can understand how they work. But I think there's some explanation that you can get out of these simple interpretable models. Next is feature importance. So like if you've ever trained a machine learning model, one of the things you probably looked at is feature importance. I mean, this just basically tells you when you train this model, these were the most important features for getting this final model that you got, right? So these are like the ones that had the most impact on the final completed model, which is good when you're training a model, not so good when you're trying to explain a very specific prediction to somebody. Just this is like overall on average, these were the strong features. Doesn't really tell you in what direction were they strong, in the positive direction, negative direction. It's like why was this specific person denied a loan, right? Why was this specific person denied bail? This won't tell you that. So what might help you there though is something called local importance, right? So this was global importance. This is local feature importance. So local feature importance is trying to answer that question. Um, for a very specific prediction that the model makes, what were the most important features and in what direction? In what direction did those features actually move the prediction? Did it move it in a positive direction or in a negative direction? So there's two very, very famous, popular methods out there that most people will refer to for local importance. The first one is called LIME. It's the Local Interpretable Model Agnostic Explanations. So that's LIME, that's the one on the left. And then the one on the right is SHAP. This just stands for Shapley Additive Explanations. So it's got some theory and some like background in game theory, in econometrics. So these papers came out, really within the last 10 to 12 years, I think. Super popular. They work on any models, any machine learning model. You can apply these methods to after the fact. You could train the model and then you can explain your predictions after the fact. It's right there in the name of both of these methods, explanations. That's what they're trying to do. The problem with these, which I won't, I mean, we could talk for hours just about these two methods. Um, they're not bulletproof. I would argue they're not even really that good, and they're very unstable. But as a data scientist, I would use these, and I do tell our students that if you're going to do local importance, then these are the ones you would probably turn to first. Visualizations are really nice. Anytime you can look at visualizations, like oftentimes there's so much that gets revealed just from plotting something. There's saliency maps, for deep learning neural networks. They try to tell you, like if you're doing image classification, they try to tell you this is the part of the image, that was what the model was looking at when it made a prediction. It still doesn't tell you why it made the prediction, which is kind of a weakness of it. It just says where. It's like this is the area that it was looking. On the right, for transformer models, which is the type of model that's being used, for LLMs and in natural language processing in general. There's lots of different little visualizations, interactive and animated, that you could look at that try to show like how these words were being predicted. Um, you know, Issues with these, right? They're very complicated to look at. I mean, it's hard for the average person to even interpret a box plot, right? So some of these might not really be all that useful if you're trying to explain it to somebody. Counterfactuals is almost trying to answer a different question. It's like, again, if you're applying for a loan and you got denied, a counterfactual might be able to tell you, well, if your income was 10K higher, then the model would have approved the loan, right? So in that case, it's trying to really just explain that, for these specific features, if they would go up or down a certain amount, then the outcome would have been different. There's kind of a disconnect though between what it's telling you, how the model was actually built. So maybe a slight weakness with this is that, black box models usually have a ton of like weird features in them. And then these try to give you simple explanations, which might not be like a one-to-one connection. Causal inference is more about like identifying causal relationships. As you're probably aware, machine learning models and generative models, it's all associative relationships. It's just correlations and patterns that they're looking for, not really identifying causation. This is kind of a new area, maybe over the last 5, 6 years, really trying to understand deep learning neural networks and open the hood and deconstruct it. And that's mechanistic interpretability. I don't know much about this. I've just started reading about it, but the goal is let's make these huge networks more interpretable, um, somehow by reverse engineering it. So what the weaknesses are, yeah, I don't know. I don't know. I guess that remains to be seen as it's a very active area of research. So kind of going back to the interpretable models, um, this, so Cynthia Rudin here, she does a lot of work on convincing people that these very small, very sparse models are the way to go. One argument that people will make about like not using logistic regression and not using this decision tree is that they're not accurate. They're not that powerful. You have to use the black box random forest model or a neural network to get the performance that you want out of the model. Um, and I would disagree with that, right? Like I definitely experienced this um, at work where we would have the neural network model running, and then after a while we decide to shut it off. We shut it off and we keep the logistic regression model running because the logistic regression, the interpretable, small, sparse interpretable model, was doing just as good as a neural network. So it's like, why have this complicated thing running that we can't even really explain? That's really difficult to retrain it if we have to retrain it. Let's just shut that off. Let's go with the simple model. It works just as good. So I've seen it in practice. So yeah, I tend to agree with a lot of her work. So I guess my point here with all of that was just to hopefully convince you that yeah, there's all these tools that we have for explainable AI. They all have weaknesses. Of course, they all have their pros and cons. And I would say none of them that I've seen so far are like really good at coming up with actual explanations. Even those local importance Lyman Shap methods, they're so unstable. It's like, how do you really even believe them? Like you get the explanations out of these methods. How can you believe them knowing that they're unstable? How can you even believe them knowing that the model might not even be really all that accurate, right? Like that model might have predicted something for me that was completely incorrect, was wrong, and now you're trying to explain to me, why it made an incorrect, wrong prediction, even though I don't know that it was wrong yet. Um, so let's see, I've got a couple minutes. Just a few words on the regulatory framework. Um, here in the US, we don't really have much, in terms of uh, a right to ask for explanations. The GDPR is pretty good at this in the EU. People there do have a right to ask the company for explanation as to why a decision was made with their data. Um, there's there's a lot we could say about this, and I'm not a lawyer, but even with that right, there's plenty of ways for companies to get around it. And so, companies, they don't want to give away their secret sauce, right? They don't want to tell you exactly how their model works. And so they do have some power there, and they can kind of get around, go through some loopholes and get around actually offering real explanations. The European Union, the AI Act, doesn't really have a lot of like strong requirements for explanations. They're there, but they're not so much there to protect the consumer. It's more as just an extra requirement for the company that they just have to fulfill as part of this act. Again, more we could say on this, not enough time. So, okay, so that was fast. Um, so going back to like these domains here, you know, I think with the things that we talked about earlier, like the reasons we might want explainable AI for these domains, I think they make sense. Gaining trust in the systems, um, you know, making sure they're fair, being able to improve the model so that they're always better, and not making bad decisions later. I think that all of those things are good. But at the end here, I just wanted to sort of challenge you to think that maybe we don't need to care so much about explainable AI. Maybe we don't need to answer that question about like why does the model make the decision that it does. So let's just assume that if we could take the bias out of the model, if we know it's fair, and when I say it's fair, that means it's like fair to everybody, it treats everybody equally, whatever that means, right? Um, if we know our data is always private, if we have a concern about privacy, we don't want to give our data to OpenAI or whatever. If we can guarantee that your data is private and that it's a fair model, and it's accurate, and that's more accurate than this doctor would be, and that's more accurate than an Uber driver would be, then why wouldn't you want to just use it, right? Like why do you care? Why do you care how it works? Like, do you need to? And I think a lot of us would say that I don't care, right? Like if that machine can detect a disease that I have better than a doctor does, then that's fine with me. Let's use it. But remember, most of the population might not think that way, right? Because they really don't understand machine learning and AI the way that we all probably do. And so, it takes a little bit more convincing for them. For me, I'd say, bring it on. I'm happy. I'll use it. I'll use the AI if I knew all these things. If I knew it was accurate and it was fair and preserves my privacy and does not try to manipulate me, then I'm happy to use it. You don't have to explain to me how it works. I wouldn't believe you anyways, right? Even if you tried. So, all right, I think that's it.